sustainability at the TTC, having previously led its vehicle programs portfolio. He also guides the TTC's strategic innovation and sustainability agenda, including the ZEB initiative and Green Fleet Transition Strategy. BEM has extensive experience in vehicle programs, overseeing a $7+ billion portfolio that encompasses fleet planning, hybrid electric bus initiatives, and also the procurement of subway trains and light rail vehicles. Under his leadership, TTC has tailored its innovation pipeline and policy framework to support net zero objectives and smart city integration. So without any further ado, BEM, please.
Thank you, Dr. Shalby, and hello, everyone. Good afternoon. I just wanted to start by kind of giving some context to our work on electrification. So we started in 2017. We were asked by our board. This is before I was actually involved in buses at all, but I was working in the CEO's office as a senior advisor under Andy Byford, and Rick Leary at the time, who was not yet CEO, was the chief customer officer. The board challenged a procurement report that had come forward, which was for more clean diesel buses. And in fact, TTC had sworn off kind of being involved in anything new because we'd been burnt on new technology adoption, kind of being on the so-called bleeding edge in the past. With CNG buses, we had, it was kind of thought of as a failed experiment with the Gen 1 CNGs. We had the SRT, which was a technology that was kind of forced upon TTC by politics of the day, and had recurring issues. And so even diesel hybrid buses had been sworn off by the internal folks at TTC, saying that these are because our first gen hybrids were very unreliable. So in the lead up to this kind of pivotal moment in 2017, when Rick Leary came to the TTC, he recognized that the hybrids that we had given up on, they were still part of our fleet, but that TTC had pretty much given up on, were the same hybrids that he had seen in operation in the States at different properties, and they were reliable. He heard our concerns with them and what the issues were with those, and he said, "Yeah, we had those issues too at one property or another, but we did this, and that." And the response was, "Well, that's expensive." And then his response was, "Well, you don't just abandon the fleet. You make the requests required to invest and keep that fleet reliable." So they did that, and then over a course of just a couple of years, that fleet, which had a reliability of under 1,000 kilometers failures, in fact, it was closer to 3 at that time, increased to well above 12,000 kilometers failures. And so with that increase in confidence in the hybrid fleet and a bit of a mindset change as well, as we recognize that new technology might require greater investment or different approaches, but can still be made to work. When we were faced with the decision by the board to kind of push back, they did, and rightfully so, on the procurement of yet more clean diesels. When at that time, 2017, it was still relatively early, but there were mini fleets popping up in North America, and even and nothing still to the scale that you see today in Asia or Europe, those short few years ago. But still, there was a movement happening, and they saw that, we all saw that, and they pushed back, rightfully so. We came then back with a technology plan, a technology transition plan that would see us buying hybrid battery electric buses first, and then a pilot of battery electric buses, and then scale up over time if the trial was successful. This eventually evolved into a kind of a broader mandate of innovation and sustainability. It was innovative, this work, and the need to
Further, the culture of innovation within TTC was made apparent through this example, but others. And also on the sustainability front, it was clear to the CEOs of that time and today that we have an obligation to improve our environmental performance. And so now I'm going to spiral back down a bit towards the presentation here. So in looking at what our environmental obligations are, there are, generally speaking, two approaches. One is looking at maximizing ridership. The biggest thing that we can do, actually, from an environmental perspective, this is not an organizational sustainable perspective, but from a citywide perspective, is to increase ridership and see a modal shift from personal automobiles towards public transit. It's the biggest thing we can do by far. We've quantified it. Like the ridership impact is huge, much larger, like order of magnitude larger than the emissions of our own organization. The second thing we can do is to look at reducing our own direct emissions as well as indirect emissions. And within the direct emissions, the bus fleet is something like 80% of our overall direct emissions. And so the number one kind of climate action that the TTC can take to clean up its own emissions, so beyond advocacy for more funding for growth of the system and modal shift, is to electrify the bus fleet. And so with that context, the TTC eventually, well, actually at that November meeting and subsequent meetings, set a goal to achieve a zero-emissions fleet by 2040. This was at that time ahead of the Transform TO goal, which was aligned to the federal target of 2050. It was later that the City of Toronto, recognizing that the TTC's emissions from its bus fleet not only comprised 80% of the TTC's direct emissions, but also an overwhelming majority of the city's own, like city agency and divisions' own emissions. And so with our commitment at 2040, with the C40 Clean Streets Declaration by different city mayors, which was also aligned to 2040, the City of Toronto adopted, and not just because of us, but for a number of reasons, adopted a 2040 target, which they now hold and that we're aligned to. Our core plan is now aligned to this goal as well. And then subsequently, the Innovation Sustainability Strategy was issued and of course aligns to this goal as well. There's an interim target as well, and I'll talk a bit more about that, of 2025, beyond which we had committed not to buy anything but zero emissions buses, but we're no longer on that path. Got a bit of a sidestep, I like to think of it as. And so, when Dr. Shalby describes the title to this presentation, it included the word setbacks and challenges. So I'll dive into that some with you. I think it's worthwhile pointing out on the screen here is the third bullet that if you consider the hybrid buses we have in our fleet, the battery electric buses we have in our fleet, as well as subway and streetcar, which are already fully electric, obviously, 70% of our ridership is already delivered on low emissions. I'm reaching a little bit to call hybrid diesels low emissions. They're low relative to what we used to have before, not low relative to global emissions standards, but low to zero emissions. The bullets at the bottom are, I think, significant. So since that 2017 decision to go away from the procurement of clean diesels only, but to introduce the hybrid fleet as well as the battery electric fleet, we've reduced the direct emissions by 21% in that fleet. That's quite significant. And then compared to the Transform TO baseline of 1990, we've reduced emissions by 47%. Actually, I don't know how these sessions work. I'm perfectly happy to take questions as we go along, or just have questions at the end.
Yeah, questions.
To the end? Okay. So this slide presents a bit of a, the journey that TTC has taken. Some of us will remember growing up with the oldest GMs and large plumes of smoke coming out of these things. Of course, we had trolley buses for some time. And if we could snap our fingers to go back in time, maybe we might do that. But they was worked out largely because of the infrastructure costs. At the time, it was not, people weren't thinking about environmental consequences the way they do today. They had started to think about the health impacts, certainly when you get to the first generation hybrids and then the older metals that we still have in our fleet. Now we're talking about health impacts, and we're looking at these particular filters to remove particulate matter from the emissions. But really, when you're looking at the period of step 2 and 3 for the trolley buses and the CNG, even though they were cleaner than the diesel buses to follow, it really wasn't the motivation. So we went away from those because of just straight, kind of dollar-based business case ROI perspective, and not considering triple bottom line the way we do today. So in 2017, that decision was made. Our first hybrid bus came in June of 2018. First hybrid bus, I say, our second generation, the first of the buses along this transition. And then we had presented at that board meeting all the different propulsion technologies that were available on the market at that time. And that included CNG, because CNG is still offered on the market, clean diesel, and that would have been the latest clean diesels, hybrid, as battery electric, as well as hydrogen fuel cell, and looked at relative life cycle costs, looked at relative emissions as kind of primary, and the degree to which the technologies were proven as primary inputs to the recommendation to start transitioning to hybrid as a transition technology, and then finally to battery electric, leaving open the possibility of hydrogen fuel cell if the dollars went down, if somehow, and I'm going to portray my bias here, but if somehow we managed to cheat physics and make it more energy efficient to create hydrogen and then to use hydrogen to create electricity. If somehow we're able to do all of that, it might make sense. But at that time, you have to appreciate there was a very heavy push by the fossil fuel industry as well, not to go down this path, and in fact to adopt either CNG as a method of cleaning up the air, and then eventually it was to hydrogen. There's still a significant push in these areas. So when we look at the transition plan, like how this plays out over time, where you see there quantity of buses in the time starting before that decision in 2016 through to 2040, and that's our net zero target. So we had some hybrids in the fleet already, as I have mentioned. We added additional ones starting in 2020, and then we added in battery electric buses. The 60 on the top, you can't really see the stack on that, but that's 60 e-buses as part of our pilot. And then in 24, 25, you see these numbers increasing quite rapidly. And then you see an apparent stall, I'll call it again, the resulting of the sidestep in 27, where we get more hybrids, get 200 more hybrids. So that 591 hybrids goes to 791. And the battery electric buses only go up by 50 in that year. And to put in perspective, on a fleet of around 2,100 buses, you have to be buying between 165, 170 buses every year just to maintain state of good repair, given a 12-year life. And so with this plan, you see that we do get to retire the last hybrid. So this is even with the sidestep, but the last 200 hybrids that are coming in 2027. We retire those by the end of 2038. 2039 is really the last year that you can be running any diesels in order to be zero emissions in 2040. Charging system schedule. So, in order to keep pace with that level of electric bus adoption, we need to be deploying charge points. We have 9 garages in total. We have 9, including Lakeshore Garage, which has Wheel-Trans. It's not listed on here. So for city buses, Wheel-Trans has its own green plan as well, which I'm not covering today. Happy to answer any questions on that, but this is really focused on the city bus, which is obviously, again, the largest portion of our emissions. So what you're seeing here are different phases of deployment for charging systems. These are not chargers, these are charge points. So these are points at which you can plug in vehicles. Sometimes the chargers have a 1-to-1 ratio. Very often it's 2-to-1 or 3-to-1, meaning you've got 1 charger cabinet and 3 dispensers. And so you see that we're going across all garages rather than electrifying 1 garage and then going on to electrify the next. This presents challenges from a capital delivery perspective, for sure. But it's intended to allow each operational unit, which is the garage, to become accustomed with, in fact, what you don't see here are the hybrids that start coming in across these garages in advance of the buses. So the hybrids come in, and I talked about it being a transition technology. So if you've got a garage that only has diesels, like Queensway, for example, still, and it's one of the hardest to electrify, which is why it doesn't start getting charge points until next year. They have no experience. The coach techs at that location have no experience in maintaining electric propulsion system. But if you get a 2nd generation hybrid there, it has a onboard genset, which they are more incapable of troubleshooting and maintaining. And it also has traction motor and batteries and power electronics, et cetera, and high voltage. So all of that stuff, they start learning that on the hybrid. And then when the battery electric comes in thereafter, there's a more seamless skills transition. We also, so that's this kind of staggered deployment across garages was deliberate from a skills transition perspective. We also wanted to make sure that we're kind of spreading the love around the city and that we're not subject to, or as subject to, the influences of local councillors who might want to see their ward electrified first. And so this has really been a great tool to be able to say, in fact, even the sequence within here are based on hard constraints. We electrify the ones that are earliest, that are easiest to electrify, and we go across the city. It also makes sure that we hit the neighborhood improvement areas. And we're very sensitive to ensuring that we deploy buses there first. It really doesn't make a whole lot of difference in the long scheme of things. It might make a difference of 6 months or so, but at least we're not deploying them on Rosedale first. And then these schedules have to come together. So these are the capital schedules for delivery of buses and then for charge points. And so the first band are the hybrid bus deliveries. The second 2 rows are e-bus deliveries. And you see the solid green is funded part of our program, and the hatched green is unfunded. And then the light green is or blue is the planning work that needs to happen between procurements, between deliveries, because these are kind of commission dates that you're seeing where the numbers are. What I didn't show, and I realized I should have included a slide that shows the deficit. So one of the biggest challenges that we're facing today is we had funding approved under what's called the Zero-Emission Transit Fund of the feds and the funding approval happens for the buses and the charge points at the same time, even though the time to get chargers is longer, and the delivery risks with chargers is longer than it is for buses. And so we tried our best to mitigate that, but we're starting to see buses come in without chargers to charge them. And so there is going to be a 6-month period between now and early next year where we have as many as 140 battery electric buses that we can't charge. And it's not just a matter of the number of charge points, it's also the electrical capacity at that facility, which requires an upgrade from Toronto Hydro. Toronto Hydro is on schedule. They've been actually a great partner. I want to mention that because they're very often thought of otherwise, but for us anyway, they've been great. So the point is you have, these different capital delivery schedules, you have an integrated schedule, and then there's some significant operational mitigations that need to be deployed just to manage what we call the charge point deficit, which is short-lived, but it is still, you don't want, let's see, it's about $250 million worth of assets sitting there unused. Even for 6 months, it's not okay, right? And you have to cycle the buses in to operations so that you're not letting bearings seize up and the like. So it's, it creates an operational constraint. The benefits, I wasn't actually supposed to start talking about the challenges just yet. I'll talk about the benefits and then I'll get deeper into the challenges in a moment. So obviously, I mentioned both environmental benefit and air quality benefits. And you can see here, the annual reduction in criteria air pollutants is estimated to be about 125 tons once fully electrified. And that's from a C40 organizational assessment that they did on our program. They looked at what the impact would be. That's 29 premature deaths avoided every year. So it's, again, quite significant just on the healthcare side alone. And the reality is that even if you're not motivated to save the world, you should be motivated to save the people next to you or your child who's got asthma or what have you, right? And that's premature deaths avoided. It's 180 some odd premature hospitalizations avoided per year. Track new riders, of course, benefits around. So reliability, actually, I meant to make an unchecked box there instead of a check mark. That's not proven right now. In theory, we have fewer parts, something like 80% fewer parts in the propulsion system, and more than that, like as a percentage anyway, much more than 80% reduction in the number of moving parts, obviously between internal combustion engine and battery electric system, and so it should translate to higher reliability. What we did see on the hybrids, even though it has that we've had long enough to be able to decide was it good or bad when it comes to reliability perspective, is I mentioned earlier the older hybrids getting to north of 12,000 kilometers mean distance between failures once that necessary investment was made. On the hybrids that we brought in starting in 2018, they had reached 60 and 70,000 kilometers mean distance between failures. So we're talking about orders of magnitude, essentially close to order of magnitude higher reliability. And that means, a lot less pressure on our spare ratio. It means you've got fewer buses that are being disabled, obviously lower impacts to our customers because you've got fewer buses being disabled in service. And so there's a promise of higher reliability for battery electric buses. In theory, it should end up being even more reliable than the hybrid. Because essentially the hybrid is a battery electric bus, but with a generator. Remove the generator, and you should have more reliability. But it's not proven. Because right now, we're still in the early, and I'll talk a bit more about this later, but the early parts of that bathtub curve, reliability curve. Reduce operating noise. And I think it's worth mentioning here because most people don't realize that there is actually a payback. So if you consider all of the capital cost increase with a more expensive bus, all the charging systems as well required, you have a payback period in the late 40s, early 50s, where the savings largely driven from fuel savings, some assumptions around, like very conservative assumptions around maintenance savings to be realized starting like 5 years down the road. We're kind of assuming that in our budget numbers, but mostly driven by fuel savings. You can see, annual savings between $83 and $275 million per year. And that's after you include, you consider the cost of electricity. It's after you consider there's different delivery models that were deployed here, which are also kind of an innovative piece of this program where we partner with Ontario Power Generation, who spun off a subsidiary called Power On to own, operate, design, build, own, operate, maintain the charging systems. And so we pay them to operate and maintain them. So even if you consider all these additional costs, and it remains conservative, because what we haven't done yet is remove the costs of abatement, for example, spills, like spill containment and monitoring and all this stuff, which we're doing across all sites already. And every once in a while, there's something happens on the spill side. The tanks themselves, we just, at Mount Dennis Garage, we had 3 tanks already because of the hybrids, which consume 47% less fuel than the battery electric, just because of the hybrids, and then battery electric coming in as well. They're now replacing those old tanks. They're only replacing 2 of them, and they're not having to replace all 3. So HVAC loading is going to be less because we don't have to evacuate pollutants from the air. And so there are savings that we haven't actually, or cost avoidance that we haven't actually factored into these numbers yet. So they are conservative. I have no idea how I am for time. I must have a good amount of time still. Oh, only half an hour. Okay, I'll speed up a bit. So the challenge is a wicked problem, and I'd heard about something being wicked before, but I didn't know before taking my first course here, and it happens to be under Shoshana Sachs, Dr. Sachs, describing wicked problems. I hadn't heard of that was kind of like an academically defined thing. That's a thing that people talk about, and it's a thing that, and it kind of resonated with me. I'm not sure if it technically meets the definition or not, but certainly there is no right solution. There is no right solution to the problems that are faced in electrification. There is just a whole lot of gray, and there's a lot of compromises between technical solutions, between people solutions as well. And so, these are just some of the areas where that are impacted. But, the real point is that this is a business transformation program. It's not a technology program. It really does change the way we do everything when it comes to bus operations. So high-level impacts and mitigation strategies. So it changes the way we plan and deliver our service because of, at least today, limited range of buses, reduced service operational flexibility. We have started reblocking as well, and right now it does not require additional operators, but there is a version of the future where we have to split blocks sufficiently that would require more operators or even more fleet. On the maintenance side, I mentioned the reliability and availability remains unproven because we're in such early days with this second generation of buses. Right now, because of energy constraints at the garages, it may take up to 7 hours to charge a bus. It should only take 3 hours roughly, or less, like 3 hours from 5% state of charge up to 90% state of charge.
but because of energy constraints, we can take up to 7 hours. Emergency response. So, buses with a limited range means that they're less able to respond to diversions like unplanned service demand. And so on mitigation strategies, I talked about business transformation, the need for that. I talked about phased adoption, which you can kind of imagine helps us not just to on the skills transition side, but also to get our handle on how we plan the service, how we deliver the service, et cetera.
And then continuous improvements, this is, we get independent reviews through APTA, for example, the American Public Transit Association, which is a peer review from our peers, obviously. We have an AG audit coming in next year from the city's Auditor General, which we welcome as well. We've had additional audits that we've requested from different consultant firms.
So one of the biggest concerns of our operations is the limited range. They're not used to having to, their whole world is designed around the diesel bus. And they weren't alive, none of us were, when the different blocks were designed.
That we serve today. None of us were alive. And so those blocks were designed around limitations. They are the buses. But today, of course, we're introducing a constraint of range. And
it's significant. And there's concern as well about battery degradation over time throughout the life of the bus. And so, we have to mitigate this, and I'll talk more about it, but to mitigate this, we have contractual language to limit battery degradation. So if it goes down by more than 10% over the life of the bus, then the manufacturer will have to either replace that battery or refurbish. We actively monitor degradation. I'll show you what that looks like so far. We have introduced buses. We're starting to introduce buses at a higher than 1-to-1 ratio. So when we retire a diesel bus, we're replacing it with 5% more essentially over time to build a little bit more resiliency within the fleet. And then we are exploring en route charging, in particular for 60-foot buses, because 60-foot buses have a particularly limited range. And we don't see, even in the time that we need to replace our 60-foot bus fleet, we don't see that battery density get high enough to be able to use long-range depot charge buses. And there are a lot of things that we can do to improve battery efficiency, like the efficiency of the use in terms of reducing HVAC loading, looking at lower resistance tires while not losing traction, and so on and so forth. And of course, the industry is seeing an increase in battery density over time.
So this is a view of the ratings that we've been getting seasonally. And there's an upper, lower band here. I won't spend the time to go through the detail because I'm running out of time. But essentially what you see here is a lot more range in the fall, spring period, and less so in the summer and winter.
And that's largely driven by HVAC loading. And when you consider all the variables, and there are tons of them, like topography, duty cycle, so depending on which route you're on, you're opening and cycling the doors more or less. Loading cycles are different as well. Driver behavior differs, but the biggest variable really in range is the
temperature that the HVAC is trying to maintain within the bus relative to that.
And which kind of gets to some of the areas that we're exploring in the bottom right-hand corner of the screen. But while you look at that, I'll talk to this graph here a bit. Basically, what we've done is we've set some maximum dispatch ranges for our Generation 1 buses. That's the first 60 buses. We have a maximum dispatch range of 180 kilometers, 179 kilometers. And then for Gen 2, 241 kilometers. You can see that in the best case scenario, for Gen 2, we're above 400 kilometers. the buses that we're getting today.
But we're constraining ourselves largely because operations, like the change management piece of this, right, is not introducing yet another level of complexity where you're having to look seasonally or even daily on which route you can deploy a bus. So we're just saying all year round, don't worry about topography, don't worry about the route, don't worry about any of the variables. If you deploy on a route that's 241 kilometers or not a route, but a block, 241 kilometers or less, you'll be okay. You don't have to worry about it. You'll come back with some safe charge. Okay. It's very conservative, but it's also, I believe, a very necessary thing, because even with that constraint, our operations folks are feeling the change here. Okay. On e-bus battery degradation,
you can see, so I mean, the short of it here is that we're not seeing a lot of degradation on the battery electric buses. Part of that's because we haven't had enough
duty cycle, enough experience with them. So we can't just conclude that, there isn't going to be significant. It's too early, the degradation. It's too early to say that now. But right now it's certainly trending under that contractual requirement. And so what we can do today and what we are doing is when we're looking at smart charging, so this is now looking at not just it's looking at the capacity of the state of charge of the bus.
And it's looking at what route or what block, again, that bus is to be deployed on.
Eventually, we're going to have to look at a system that recognizes that when you bring that bus back and you go to charge it, how much energy can that particular bus take? And I say that particular bus, it's not even by procurement batch, because certainly by procurement batch, you're going to have one bus with 400 kilowatt hours on board as our Gen 1s. Gen 2s have 560 kilowatt hours on board. And so right away, that a Gen 2 bus is going to take longer, or the technology may allow it to take a charge at a higher rate. And so it needs to factor this into which lane, because we've got lane parking, which lane it's parked in, so that when it's to be deployed to service, it's charged enough at least.
So this is a projection of battery capacity over time. And we need to do this to understand, do we need to go on route right away for route charging? Or do we need to see some miracle of breakthrough, which may happen, like going solid state batteries or what have you. But even when you look at the relatively conservative assumption of 3% increase in capacity per year within the lithium-ion battery space, this has been true historically. You project that forward. This is the level of capacity you expect that's aligned with our different procurement batches. So, we're in the Gen 2 right now. We're receiving those now, kilowatt hours, and then what we can expect in Gen 3 now.
And what that allows us to do is when you take a look up a plot of all of our blocks throughout the system, and we've got very small blocks which are used really for maintenance. And this is the left-hand side of the curve here, usually for maintenance when you've changed the wheels, you send it back out to service, you bring it back over a relatively short period of time to retorque the wheels, and then you can start sending it out for longer runs. So this includes the extreme low distance blocks, and at the other end, that 520 kilometer roughly block length at the extreme long end of the range. And so what you see here in the vertical lines is where basically it's the area under the curve, or it's that reflects the number of blocks ultimately that a different generation of bus can serve.
And so with Gen 2 buses, where we are now, at the end of, since 2024, but at the end of this Gen 2 procurement, we'll have 19% of our fleet
be battery electric, and it can serve 54% of the fleet.
And so with Gen 2 buses, where we are now, at the end of this Gen 2 procurement, we'll have 19% of our fleet be battery electric, and it can serve 54% of the fleet. And so with Gen 2 buses, where we are now, at the end of this Gen 2 procurement, we'll have 19% of our fleet be battery electric, and
of our blocks. So as long as you've got a healthy enough, a safe, like a comfortable enough margin between what the bus is capable of and the number of blocks that you have option to deploy on, range, there are other problems. Range is not actually one of them, at least, if things progress the way they have. If there's a breakthrough, as we understand from our OEMs, in 2030, they're thinking there's going to be a breakthrough. We don't actually know what it looks like because the battery manufacturers are being very hush about it, but we understand that there's going to be a breakthrough that's going to be beyond that 3% increase, and there'll be also an improvement in charge rate. E-bus reliability and availability. I'm going to talk a bit about this. I'll start skimming stuff here. I talked about the back curve. And what you can see here in blue dots are the hybrid reliability. And you see it normalized quite quickly. So there was some, number of defects per 10,000 kilometers in the y-axis. The number of defects was quite high to begin with.
It's a proven platform. So as you'd expect, when you undergo mods in the first 3-4 months of receiving the bus, you really can start getting on top of those reliability issues. On the battery electric bus, it's still 90%, more than 90% of failures are non-propulsion related. So it's doors and HVAC, steering and the like. And
last week's issue was that operator security barrier clip failed, a piece of glass had a chance to come out. Nothing to do with it being an electric bus. But we're hunting those issues down, and we're hunting down the propulsion issues as well. And what we expect to see is a normalization of that reliability down in and around the hybrids, hopefully even better, as I mentioned earlier. Facility power constraints, I've talked a little bit about this. I didn't talk about software integration, but that's a huge challenge. So we have, for the first time, the need to upgrade power at the site. So we need in fact, we have to establish a microgrid at every garage. So we have, right now, typically diesel garage would have maybe a 1,000 kVA supply. That needs to increase to 15 megawatt supply. We need a customer-owned substation. We need a new feed, obviously, from Toronto Hydro to enable that. Ideally, redundant feeds from different transformer stations within Toronto Hydro to provide the reliability that we need. And we have energy storage on site. So at 3 of our garages so far, we've got 4 kilowatt hours or megawatt hours, sorry, of energy storage. And we've got solar being deployed. We've got buses and charger loads. We've got HVAC that's going to be converted over to heat pump as well. So we need control systems for managing the energy on site in the way we haven't needed before. These systems need to talk with our CAD-EVL or like our scheduling systems in order to understand what service needs to be deployed. So it is a very significant, and I mentioned, so the smart yard is mentioned here. I mentioned needing to know where the buses have to be positioned. I talked about this already. I think I've covered that. If we have any time at all, at the end, I'll show you a live version of the Better Fleet system, which shows you, the power, the like real-time power demand of each garage. And then I've talked about most of this as well. I'm just trying to save some time here for questions. Vehicle signing and reblocking. So this is really a big pain point for operations. Again, I've touched on it, but tagging is just the effort of looking at which blocks are e-bus compatible, which ones are under 241 kilometers. I mean, it didn't, there's not a lot to it, but it is a source of stress. And there's a desire for us to automate this as much as possible. So essentially, it's not a matter of dispatcher having to look at the start of charge, having to look at the rate at the route that it's going to be, or the block is going to be deployed on. But instead, you just do what they do today with a diesel bus, which is assign an operator to a bus. Reblocking, essentially, I mentioned reblocking earlier, and I think everyone online probably and everyone in the room knows what that is. But generally speaking, what we're looking at doing is taking those long blocks I mentioned, 520 kilometers, and maybe cutting off a certain amount of that block, maybe adding it to one of the shortest blocks. So in that case, you're actually squeezing that bell curve in to be a bit more narrow, and making a larger percentage of your fleet e-bus compatible. There are potential workforce impacts, as mentioned there. So there are kind of desired shift durations, which also impact, the degree to which you can do this stuff, because operators are unionized, of course, and if they want to protect a certain time at the beginning or the middle or the end of their shift, then us playing around with block lengths has an impact. So really what I'm describing again is a very large scale, complex business transformation program. And that has a lot of challenges, all reasonable, I think, and solutions. But nonetheless, it's a path we need to undertake. So in terms of gaps, operational cost, savings, uncertainty. So this is largely because most of the uncertainty around the cost savings, you saw that big range in cost savings. Most of that uncertainty comes from the uncertainty over energy costs. How much is diesel going to cost in the future? We look to U.S. Department of Energy for that. How much electricity is going to cost more locally? We look to that. How much of the cost of electricity is going to continue to be subsidized? Who knows? The degree, does the GA, the global adjustment model that we currently have now, gonna persist? And so is it worth the investment in energy storage to manage the time of day use? Just purely, it probably is from a scope 2 emissions perspective anyway, but from a dollars and cents perspective, does that make sense? So there's a lot of uncertainty there. But we have, I think this whole endeavor, I mentioned it as a wicked problem. One of the things that we need to do, recognizing that's a wicked problem, is understand the level of uncertainty when it comes to certain decisions, and figuring out whether that level of uncertainty is something that we can persist with or not, right? And where we can't, then we need to either dive deeper to understand better, to better inform the risk and the timing of risk. But as I mentioned, I believe anyway, with some bias, that these risks are manageable. Unknown service life. So, even in the systems that around the world that have battery electric buses at a large scale, like in Asia in particular, like nobody's run a couple generations of battery electric buses to know firmly, what is the life of a battery electric bus? Is it still 12 years, as bus lives have been forever, or is it something else? Maybe it's longer, maybe it's shorter. Battery reliability concerns. There's all kinds of issues. Like when we do have problems with the propulsion system, it is always a battery issue or a battery control issue. It's containment issue. It's the different cells being unbalanced. There's all kinds of issues with batteries, and we need to get through this kind of technology maturity phase here. And data deficiency. There's all kinds of data. And you can imagine as I talk through these different systems and talk with one another, just the amount of data that there is. Advanced modeling tools. And I know that many of you here, or some of you at least, are involved in modeling some of this stuff. And so I think it points to the fact that academia
is on point to pursue the, kind of answers to the solutions that we need. And
standards on, this is on life cycle costs assessment standards. Those don't exist, but there's no standards on any of this stuff, really. And ideally, we get to a point where we have standardization and that level of maturity within this emerging part of the industry. That's it. Yeah. Thank you.
Thank you so much, Bill.
Thank you.
Floor is open for questions to that.
I've got one, and before I hop into it, I want to say thank you because I have the e-buses in my neighborhood a lot, and they're much quieter. I love riding them; they're great. But my question or questions is, oh, sorry. Another bit of questions, two-part. First one is just in terms of maintenance and working jobs. I'm wondering if you have any feedback from employees there and how the process has been for reskilling if needed to do maintenance work on the e-bus fleet versus the conventional fleet. And the second part is just out of curiosity. You mentioned earlier on in the presentation trolley buses, and I'm wondering if there's any research being done in that, or if you're looking at that as maybe a potential option for certain routes in the city, or if that's not even being considered, because I traveled around quite a bit. I see them in other cities. I know Toronto used to have them, and I think they do solve in many ways a lot of the problems associated with e-buses that I think and hope over the long term will be resolved just through technological advancement. But in the short and medium term, I see potential there, and I'm curious what your perspective is. On the maintenance, it's interesting. Sorry.
Online audience is asking if you can repeat the question.
Oh, okay. So so the first question was, what are we hearing from the kind of shop floor from the maintenance personnel? And the second question is, are we considering trolley buses as part of the solution going forward? So on the maintenance side, it's a mix, as you would expect, right? So I mean, there are people who don't like change. I remember when we were first entertaining this, we got, at the time, there were only 3 bus OEMs that were manufacturing long-range battery electric buses. We got a demo bus from each of the 3 to go around each of the garages and have and be there for multiple shifts to allow for both operators and coach techs to kind of kick the tires, put them up on a hoist, take a look at it, get a view of what the future is. And it's interesting that it was very mixed at that time. There were people who were there who were about to retire within a couple of years, and they're like, "Oh, this is amazing! This is the future!" And they're telling their young apprentices, "This is for you," basically. And they're also saying, "Oh, thank God, I'm going to be retired." And then, and I think that's kind of played through, meaning that there is a general trend, I would say. I hate to call it, I hate to be ageist, but there's a general trend between those who are closer to retirement, who are just not interested in the change itself, and those who are embracing it more fully, who are earlier on in their careers. Generally, though, not absolutely, because there are others who are like saying, and who continue to say, "I wish I was just starting now. Right? I wish I was just starting my career now." And but the most recent thing I heard from the shop floor earlier this week, what is it? Wednesday? Yes, it was Monday. Was just don't buy that bus, buy that one. So it's not about whether it's electric or not. I mentioned the issues that we're having are largely not about whether it's electric. They have a favorite bus. If it's electric.
And to me, I'll take that any day, right? Even though I can't single source, $4 billion to one company.
So it's not like, on the second question around trolleys. So it's interesting you mentioned that because
we had the APTA peer review recently, which was concluded in September. They provided their final report. I know that there is an appetite among some of the bus maintenance folks to have hydrogen fuel cell. I think hydrogen is like fuel is like this thing that
is more easily relatable than the electron. And like, what's an electron, right? So I think, there still feels to me a desire to have a gaseous fuel or not a fuel. I personally do not think that's reason enough to incur the added expense or, and again, I'm portraying a bit of it's not a bias. I would say it's an informed, actually, I should stop calling it a bias, but it's, it's just, I don't think it makes sense and also keep in mind that hydrogen, I know this wasn't your question, I'm going to get to it, that hydrogen fuel cell might increase your range by 50%. But you see from these numbers, if you increase the range by 50%, it still doesn't solve our problem. Like the challenge, you still need an increase in battery capacity to get you to that 520 kilometers without reblocking, if that's the goal. The reality is that you can do a certain amount of reblocking and your operations actually becomes more efficient than it was before. And so for me, that's not something to be shy away from. Trolley buses, I did ask, out of that review, the APTA review came fleshed out again, this kind of desire, because I deliberately had asked that they touch base with each stakeholder and understand from each stakeholder, how well things are working from a kind of stakeholder satisfaction perspective. So it came out of that. And I said that we would take on a renewed study. So it's not about what BEM thinks. It's just a new study by a third party on whether we're taking hydrogen. I asked the team, make sure you include trolleys as well for the very reasons you're mentioning. And the reality is that it is a very low risk thing. Whether the city wants another line in the sky above the roads, probably your biggest constraint, which, as ridiculous as it might sound, compared to all of the other risks that it actually mitigates. But if you've got a dedicated, if you've got a route that typically, especially for 60-footers, right? I mean, for the 60-footers, if you're looking to do en route charging, lots of risk there. If those 60-footers, by the way, are also the ones that Rapid TO initiative has identified as being ones primed for dedicated rights of way. And so it works perfectly if you put the trolley there, right? So we'll include it in the study, and we'll see where it goes.
Thank you.
Good, that's very good questions. Yeah, I'm long-winded on the answers. Yeah, I apologize.
Actually, mine probably, Solaris was in town recently and they got the Vancouver contract. They were in doing some presentations. But do you look at any other advanced technologies, any new autonomous systems, that type of thing?
Well, I'm charging, just to finish the charging off. We're also looking at inductive charging. We'll have an inductive charging trial in the next couple of years. Again, I mean, again, it's kind of a physics problem here to kind of limits the degree to which it can be efficient relative to a contact system. But anyway, we're gonna try it, and we'll understand things like how well it works,
weather, and when do you have to heat it or not, and to prevent ice buildup and the like, and is it reliable, and how do you maintain it and such. So I think it's worth learning more about it, and so we'll have a trial on that. We have a trial right now. This is not going to excite anybody, but we have a trial right now for some very low level automation, which is driver safety assist technology. And all it is a camera-based system that looks outward and identifies potential collisions and advises the operator to respond. So it's low-level automation. Those vendors are not, they don't design their systems to a certain safety integrity level. They're not they're not robust enough to be able to rely on to apply emergency brake or to apply the brake on itself or steer or whatever. So they for liability concerns right now, to this point, they don't go that far. We know that there are
Bus Williams, New Flyer is the only one in Canada that has trial in Connecticut, I think it is, within a physically separated right of way, which we don't have. But we are talking with them about how we might apply the same technology to enable platooning with a human-operated lead bus and a trailing bus that is operated autonomously. I think that has huge potential. So even without, going up against this
complex problem when you're looking at removing human operators from a labor relations perspective, and obviously there's not a very good just skills transition path there. But even without coming up against that, you could, without decreasing the number of operators that you have, increase the capacity by adding a bus to the end of that through a virtual coupler, essentially, to the back of that bus. And so now, on Dufferin and on Bathurst and elsewhere, again, those Rapatio routes that could, they're not quite at the point of justifying an LRT or an LRV line, but you could actually get up to LRV. In fact, you could exceed LRV capacity with platooning. So I'm really excited by that prospect. There's all kinds of little things as well, like semi-active suspension seats, so you take the technology that's in your noise canceling headphones, and you cancel out the structural borne noise basically within the seat to reduce a vibration for operators. There's lots of little things as well.
Any other questions?
Any other questions online? Nothing online? Yeah.
Nope.
Remembered the button this time. Thank you for the answer earlier. Just one more follow-up that I'm kind of curious about, going back to the shop and maintenance on the e-buses, is I'm wondering if you've had any instances of collisions or major accidents involving an e-bus, and in terms of the recovery of that asset, is it comparable to that of a traditional diesel, or is it a write-off, or what does that look like for you? Because I believe the TTC self-insures, so I could see that being long-term, like a considerable cost pressure.
No, we haven't had major incident. We've had minor scratches and bumps and stuff, but like any other bus. But no, we haven't had a major kind of asset loss as a result. There is a lot of work. I mean, there's kind of like maybe a tangent subject around thermal runaway and loss from fire. And so there's a lot of work to mitigate that risk, which really wasn't your question again, but no, we haven't had the losses yet. In terms of the emergency response, before we brought on any buses at all, and then with every new generation of bus, we train first responders, because we don't know who's going to show up, but typically it's fire, but it could be others as well. So we train first responders on how to do the lockouts, confirming what you can spray on the battery if it's in thermal runaway. We have a number of set points within the battery management system that will advise us of a problem long before it actually gets to the point where you see smoke or you see any flame through, like long before that. It's a fairly slow process from when you're looking at,
It's actually like 25
degrees Celsius is when the first threshold is reached, because the temperature should be maintained below that. Whenever we've had alarms, it's only because really the energy management system itself has a fault. But nonetheless, transit control, bus maintenance, the city of Toronto, first responders are all trained, and there's procedures in place to